Welcome. I'm Scott Litticoat, and you're about to take a virtual tour of a typical commercial building. In some ways, it might be like your home.
But on a much larger scale. A commercial building is always big, so it will have big health and comfort needs and big systems to provide for those needs. A commercial building will have a much bigger cost to operate compared to a home. For that reason, its big energy systems are often managed digitally or automatically. You're taking this virtual tour so you can understand how big energy systems in a commercial building look, how they operate, and how they can be controlled so they run efficiently. You're looking at a skeleton drawing of a commercial building. It's not an engineering diagram, but it shows some of the features of an engineering diagram in an understandable way. You should have this drawing in front of you right now.
Mostly, it shows how
heating, ventilating, and air conditioning systems work to provide comfortable conditions for a typical room in a commercial building. Here is a typical room. You may think of your classroom as a typical room in a commercial building. If your school is big enough, it will be designated as a commercial building. Commercial buildings are classified as large supermarkets, department stores, warehouses, hospitals, hotels, office buildings, and schools. Other big buildings may qualify as long as they're not related to residential, industrial, or manufacturing enterprises. If your classroom needs heat, it probably gets it from a building furnace or boiler, which is shown here. If your classroom needs air conditioning, it probably gets it from a large commercial air conditioning system. In most commercial buildings, air conditioners, furnaces, and boilers work with an air handling unit to provide cooling and heat to the whole building. Once heated or cooled, it is called conditioned air. Conditioned air is distributed throughout the building through the ventilation system. At the same time the building is conditioned, the ventilation system is exhausting stale, return air from building spaces. The return air is then freshened with air from outside of the building before it is filtered. This mix of return air and fresh outdoor air is blown through heating coils or cooling coils and distributed to spaces in the building. Individual rooms or spaces often have a way to boost heating and cooling if the bulk or whole building supply is not enough. There are always losses from the system. Engineers try to keep them to a minimum so the whole process is energy efficient and saves money.
This lesson will also take you through how an individual building automation system application works.
Recall that in an individual BAS application, you'll always find an input sensor, a digital controller, and a mechanical actuator.
Now that we've had this overview, let's take a closer look at a commercial building, system by system, starting with
you. Commercial building operators work to keep indoor climates healthy, comfortable, and productive for you at the lowest possible cost.
Accomplishing these objectives at the lowest possible cost also means we use the fewest resources and reduce environmental pollution as well.
Today, cost, resource, and environmental savings are no longer secondary, but are primary objectives for many businesses, along with health, comfort, and productivity. Businesses want to be perceived as green in the public eye. Here you are in a room. In your case, it's a classroom, but in other types of commercial buildings, it may be an office, a store in a mall, or a section of a department store, or a supermarket. In each of these spaces, you'll find the same three things you'll find in your classroom. First is a sensor. There may actually be several sensors, but you should be able to find a climate sensor in your classroom. You might call it a thermostat. At home, your thermostat probably performs three functions: sensor, controller, and actuator. Your classroom thermostat is only a sensor, sensing the temperature and sending that information to a controller in real time. In your room, you should also find two features that are probably on your ceiling. One delivers fresh, conditioned air to your room. It is called a supply air vent. Often, it is just called a diffuser because the baffles on its surface help to evenly distribute or diffuse the fresh, conditioned air in a building space. The second one is usually less noticeable. It takes air out of the room and returns it to the air handling system to be refreshed and conditioned. It is usually called a return air grill or return air vent. What happens to this return air?
What happens to this return air?
During the heating season, it may be heated by a furnace or boiler. Shown here is a natural gas-fueled boiler. Inside the boiler, natural gas is burned. The heat from that burning or combustion reaction heats water. Before we show you a boiler burning tube, consider the requirements for natural gas to burn in the first place. Adequate oxygen must be available for natural gas to burn safely, cleanly, and completely. Oxygen may be supplied to a boiler or furnace in a variety of ways. Here is one. Supply oxygen to natural gas, spark it, and it will burn and produce heat. Here is what that combustion reaction can look like inside a metal boiler tube. With this type of boiler, water is circulated around the outside of the tube. Naturally, the water outside the tube heats up. It will be used to heat the entire building. You might know that a combustion reaction of this kind produces a waste gas, carbon dioxide, CO2. The carbon dioxide produced is exhausted from a boiler this way. The hot water from the boiler is pumped through insulated pipes to a large air handling unit. Here you see heated water being pumped away from the boiler. At the same time, water that has had heat removed from it is being pumped back into the boiler for reheating. The heated water arriving at the air handling unit is pumped through a heat exchanger, usually just called a heating coil. Take a closer look at this coil. From one large pipe, heated water will be circulated through many smaller metal pipes. Each of these small metal pipes usually has lots of aluminum fins attached to it. These aluminum fins allow much more metal surface area to heat up. Freshened, filtered air returning from the building is then blown through the heat exchange coil. Naturally, as the air crosses the heat exchanger, the air heats up and the water inside the coil cools down. The cooled water is pumped back to the boiler for reheating. And what do you suppose happens to the heated air? That's right, it's used to heat the building. You might be sitting in a classroom that's being heated just this way right now. Of course, the boiler will be shut down when it is not heating season. During summer, preventative maintenance will be performed so that when the heating season arrives again, the boiler will run efficiently.
How is comfort controlled in a room like yours during the cooling season? You already know the answer. Air conditioning.
You might think of a commercial air conditioner as something like a window, home, or vehicle air conditioner enlarged to service an entire building. This is a commercial air conditioning chiller unit. It is always located outside because we want heat from inside the building to be moved outside. As you might expect, the fans are pulling air through a heat exchanger here, releasing heat from the building to the outside air. Air conditioning systems typically use a special fluid called a refrigerant or coolant to transfer warm indoor air to the outdoors. You see that heat exchange happening here. These fans are removing heat from the refrigerant, which contains heat that came from inside the building, and releasing it outside. We won't get into the details of what's called the refrigeration cycle here, but the refrigerant works much more effectively to transfer heat to the outside air from the chiller than water ever could. This is especially true when the heat from the building we want moved outside is not as hot as the outside air, which is usually the case. Earlier, through a separate heat exchange, the air conditioning refrigerant took building heat from water that was pumped outside to the chiller unit. Having given its heat to the refrigerant, the water is cooled down and pumped back inside to the building air handling unit. In the air handling unit, the cooled water cools and dehumidifies, the air being forced through it in another heat exchange. The air conditioning heat exchanger, usually called a cooling coil, probably resembles the one for the boiler in the air handling system. But here, as warm air is forced through this coil, it is cooled and dehumidified. Then it's circulated throughout the building. Of course, the cold water in the coil is warmed in the process and is sent back outdoors to the chiller again.
And what do you suppose happens to the air that's cooled and dehumidified in the air handler?
Of course, it's used to cool the building. You might be sitting in a classroom being cooled just this way right now. You may have noticed a big difference between air conditioning and boiler heating in this discussion. The boiler needed intake air with oxygen in it to burn natural gas cleanly and effectively. The waste carbon dioxide produced had to be exhausted from that combustion reaction. With air conditioning, there is no intake air needed and no exhaust to be dealt with at the building level. Why is this? Air conditioning runs on electricity, and electricity is a secondary source of energy. A natural resource like coal or natural gas, primary sources of energy, almost always needs to be consumed in order to make the electricity we use. When coal or natural gas is burned at a power plant, it needs intake air, and the waste carbon dioxide from the combustion reaction must be exhausted there at the power plant. We don't see the coal, we don't see the waste gases, but they are there at the power plant. Here are the heating and air conditioning systems we've reviewed together. Do you notice any other similarities? Any other differences?
HVAC stands for heating, ventilating, and air conditioning. So far, we've examined the
H for heating and the AC for air conditioning. Now it's time to look at V for ventilation. You'll see that ventilation brings everything together. Let's take a brief look at ventilation. Return air is pulled from many rooms and building spaces. This return air is in need of freshening, filtering, and usually needs conditioning, heating or cooling, as well. After freshening, filtering, and conditioning, we now call it supply air, which is distributed to rooms and building spaces. Once used, it becomes return air again and is sent back for freshening, filtering, conditioning, and so on and on.
Now that you have the main ideas, let's take a closer look.
Once again, return air is pulled from many rooms and building spaces. As more and more return air is collected, the ducts collecting it become larger and larger. As these ducts get close to an air handling unit, they merge together into one large return air duct. This return air is in need of freshening, which involves exhausting a portion of the return air to the outdoors and adding some fresh outdoor air to the return air. Here we are on a rooftop, just above an air handling unit. You're looking at exhaust and fresh air intake vents. Each one has a hood over the top of it to keep rain and snow out of the system below. Just below the hood are adjustable louvers. These regulate the volume of air to be exhausted and brought into the building according to occupancy standards. You saw a video of louvers being opened in Chapter 1. Return air is exhausted to the outdoors by forcing it through the louvers and out from under the hood. Fresh air is pulled in from outdoors and under the hood. It moves through the adjustable louvers and into the air handling unit below. The return air has now been freshened. Next, it will be filtered and conditioned in the air handler.
The air handler. To show you how it works, we'll take you for a quick sprint alongside an air handling unit. After that, we'll take you inside.
Here's what an air handler looks like. One or several blower fans force the freshened air through the filters and heat exchangers that follow. And then out into rooms and occupied spaces throughout the building.
Now let's do that again, and this time you'll see what the process looks like as we open the doors to the air handling unit.
Remember, return air has been exhausted and freshened. The blower fan forces return air through the air handling unit. To remove dust and other particles, the freshened return air is filtered as you see here. Sometimes this step happens before the blower fan in the air handling unit. As we've talked about, heated water will flow through the heating coils during the heating season. If heating is needed, return air can exchange its cool air for warm as return air is forced through the heating coils. Also, as we've discussed, cold water will flow through the cooling coils during the cooling season. If cooling is required, return air can exchange its warm air for cool, as return air is forced through the cooling coils. When this is done, we can now call the freshened, filtered, conditioned air supply air. Building supply air is forced through smaller and smaller ducts as it gets closer to its destinations. One of those destinations might be a room just like the one you're sitting in right now. But what happens if the room or building space you're in isn't adequately cooled or heated? And why might that happen in the first place?
Perhaps it's heating season and the room is on the north side of the building.
Cold winds often approach buildings from the north during the heating season, so building spaces on that side might have heating needs that the rest of the building does not. What happens if the main or bulk supply of heat isn't enough to keep occupants comfortable in the north side room? This situation gives us the perfect pretext to talk about smart controls, called Building Automation Systems, or BAS. Room adjustable local control is usually provided with an individual BAS application for heating and cooling. Let's review how it works in this case. The room sensor, which is constantly monitoring temperature, sends its information to a controller. Remember, a sensor, the first of three parts in this system, is a device that measures an environmental variable and relays that information in real time to a controller. The controller is a digital processing system that collects data from sensors, monitors the data, and relays digital commands to actuators based on its programming. In this case, the controller has been programmed from a computer with high and low temperature set points. If the temperature goes above, or in this case below set point, the controller activates an actuator to raise the temperature. An actuator, the third of three parts in an individual BAS system, an actuator is a mechanical device responsible for moving or controlling a mechanism within the equipment. In our case, the actuator physically or mechanically opens a valve, allowing some of the hot water from the boiler to be pumped to our building space. The extra hot water from the boiler enters what's called a variable air volume VAV box, which is located real close to the room that needs the extra heat. You might think of a VAV box as a very small air handling unit. Opening the right valve, an actuator permits hot water from the boiler to enter the VAV box. Then the hot water circulates through a heat exchange coil. This is sometimes called a booster coil because it's giving an extra boost of heat, in this case, to already heated air. Air from the building or bulk air supply that isn't quite warm enough is blown or forced through the booster coil in the VAV box. The booster coil provides additional heat to the air moving through it. That extra heated air then enters the room or building space that needed the extra heat.
You could probably figure out the rest of the story from here.
The sensor begins to sense the boosted temperature. As the higher temperatures approach the programmed set point, the controller activates the actuator again. This time, the actuator physically begins to close the valve and may eventually fully close it.
Something should be pointed out here that should now be easy for you to understand.
What will happen if the room space we've just talked about has a window that's been left open to the outdoors? As heat leaves through the window and cold air enters, the room space will be constantly calling for and receiving booster heat that isn't needed.
This is extremely wasteful.
It wastes money, it wastes natural gas and energy resource, and it puts unnecessary waste or pollution into the air. A system like this, which is automated to deliver comfort and efficiency, is only as good as its human interface.
But if people are educated like you are becoming, and the system is set up well, which you are learning to do,
it works exceptionally well to provide comfort, efficiency, cost savings, and environmental savings.
a commercial building may have thousands of individual BAS applications located throughout that monitor and control
heating, cooling, ventilation, lighting, fire control, building security, and more. In addition, BAS usually monitor individual components of each system and will alert building managers when problems are identified.
Building automation technology is quickly changing energy management everywhere it's applied, which is literally everywhere.
BAS technology requires installers, troubleshooters, and network specialists with an understanding of HVAC, which was kind of the point of this lesson. Jobs that used to be called maintenance are now called engineer or network specialist. These jobs require expertise in just what you're learning, but also require creative thinking and teamwork. They pay really well, and there is strong potential for advancement. And since smart jobs like these bring about energy, money, resource, and pollution savings, employment in this field can be incredibly personally satisfying.
Finish this lesson strong. Keep up the good work and continue your smart start learning about building energy management.